Hi students, welcome to VTeach. So necessity of 3-point starters and 4-point starters. For today's session, we'll discuss about necessity of starter first. So what is the necessity of starter in case of DC machines? So before going to the principal operation of starters, so let us see how to, we have to understand that the basic principles of based on the starters. So here in case of DC motors, I can say that these are self-starting type. So that is nothing but here any other external method which is not needed for starting of these DC motors basically. So but just by appropriate field and armature supply which are given to that motor, it starts automatically. That's why they do not need any external additional devices for starting purpose. So, but in case of DC motors, at the time of starting, so when we are initially at the time of starting, so that is speed is equal to 0, and whatever the when speed is 0, so the back EMF value of the DC motor is also going to become 0. From when the back EMF is initially, so that is at the time of starting. So at the time of starting. So if these conditions which are going to be applied in case of motor at the time of starting, so already we know that EB is equal to V minus IARA. So this is the voltage equation we have derived from the equivalent circuit of the DC motor. So that is a back EMF value which is calculated as V minus IARA. And from this here we can write what is the value of the IA value. So that is IARA is equal to V minus EB on this equation. So here IA, so that is equal to V minus EB divided by RA. So if you apply these conditions here, therefore IA is equal to what we are getting, V minus EB value is 0 at the time of starting. So therefore V by RA. So now let us consider if the whatever the terminal voltage of that motor, if it is given as some 230 volts, so then 230 minus 0 divided by, if the armature resistance, if it is given as some 0.5 ohms, then 230 divided by 0.5, so here we are getting 460 amperes. Suppose here, now how much current? 460 amperes we are getting, that is at the time of starting. So that is initial armature current, which is the motor which is drawing a current of, so 460 amperes which is going to be taken. So therefore which is almost with that corresponding armature current, so that is which is almost easily that is 10 to 15 times of the normal rated current of the motor which is going to be flowing through this motor, and it is going to damage total parts of the DC motor. So that is nothing but here the total winding of the DC motor, it is going to be damaged. So why? Because so at the time of starting, so due to this the speed of the motor is 0 and the back EMF is 0, so it is almost 460 amperes which is going to be taken into the armature part, and it is going to damage total windings. So that is 10 to 15 times which is going to be flowing through this motor. So that's why definitely here the I current which is flowing. So our aim is now to reduce this armature current. So whatever this initial starting current, so that could be minimized. So our aim is to minimize this total starting current. So as everybody knows that how to reduce the current. So that is nothing but if we insert some resistance. So here basically this is the motor. So here we have, these are the brushes, and this is the which is giving IA value, and here we have some resistance, armature resistance of RA, and here so this is the whatever the back EMF which is going to be produced in this motor. So when IA value, so that is here we need to reduce, so this is almost 460 amperes which is going to be flowing through this armature part. So now we have to reduce this armature current. We have to reduce this armature current. So that is initially whatever the starting current. So how to reduce this current? So that is nothing but here already we have some RA of, so initially we have taken that is 0.5 ohms. So everybody knows how to reduce this resistance. So that is nothing but if I add some other external resistance in series with the armature resistance, such a way that, so this whatever the 460 amperes initial starting current, which is going to become minimized, So in this way, we can add some other external resistance to this armature circuit in series, such a way that initial high starting currents are going to be limited, So if you apply the same case in here, so now here whatever the excessive current which you are getting, so that could be minimized by using or by adding external resistance in series with the armature circuit, so such a way that high initial starting current going to be limited. So for that purpose, we need a starter. So here starter is nothing but resistive element. So that is called resistive element. So that is external resistance. This could be added in series with the armature resistance, armature circuit. That going to be added in series with the armature circuit. So in this way, we can limit this high starting currents. So that is what during this transient period. So when the excessive current flows, so if it is not limited, so that it is just like if you leave it that if excessive current is flowing in this circuit, so then the torque developed is also be excessive. Why? Because torque. So torque is proportional to phi into Ia. So this is the equation we have derived. So if Ia is increases here, and torque is also going to become excessive. So therefore, with this result, the motor would get damaged both electrically and mechanically. Yes or no? So if this excessive current, if you are not limiting, so then here excessive current, armature current is exceeding, and it is going to be increased. So meanwhile, the torque of the motor is also going to become excessive, and it is going to become damaging both electrically as well as mechanically. So we need to protect this motor. So we need to protect the motor from such damage. And also for that purpose, we are using, that is the method, that is resistance is introduced in series with the motor, which is as shown in bigger below. So how we can include the series in resistance in series with the resistance with the armature resistance, so such a way that we can limit the whatever the high starting currents. So for that purpose, I can say that we need a starter to limit high starting currents in case of DC machines. So that is the basic arrangement of DC motor starter, and its operation is totally manual. So but here practical starters which have been developed with some additional protective and automatic starting features. So they are called 3-point starters and 4-point starters. So that is the purpose. So because of this reason, we need to go for starters in case of starting of DC motors. Thanking you.